Everybody, today we're going to be looking at 8.1. So we're going to be getting into trig for this quarter, and it's going to be mostly the whole quarter looking at trig. So a lot of students like this unit, especially in the regulars, because it's a very visual unit. I'm going to show you a lot of tricks and tips today on how to make these easy. If you have 3 color pencils, markers, pens, highlighters, then that's going to make your life a little bit easier today. I'm going to be using red, blue, and green, but the colors really don't matter. Just make sure you're consistent with what you do. Once we get to graphing, I would highly recommend that you get about 5, but for today, all you're going to need is those 3. So if you need to pause the video, go grab those. I would do so. It's going to make your life a little easier. So today we're going to start off by looking at sine, cosine, tangent. This video is going to be broken up into 2 parts. If you're an honor student, you do need to watch both parts today. And if you're a regular, we're only looking at the first part today, and we'll look at the second part next time. So for today, we're going to start off with Pythagorean's theorem. So this should be a Math 1 topic for you. Remember, Pythagorean's theorem is a squared plus b squared equals c squared. Okay, the rules here being that it does need to be a right triangle, and c squared has to be that longest side, that hypotenuse. And we'll get into that in a little bit. So please be careful when you're doing these, but getting that longest side, especially if your triangle's not turned nicely like this one down here on number 3. Okay, now a trick, and it's a little harder to show you because I'm not in person, but a trick to fixing your triangle if it is turned the wrong way. So for example, this one is very similar down here. If that triangle is bothering you because it's turned the wrong way, turn your paper. Okay, so that's a trick. Some people, it really bothers them that the triangle's turned the wrong way. Just turn your paper, and then it's turned the right way. But again, it doesn't really matter. It's not going to change anything. But some people, it helps with that visual part. So that being said, we're just going to plug in. Now again, c squared does need to be that longest side, but the other 2 sides can either be a or b. Doesn't matter. You'll get the same answer. So we're going to start off with 3 squared plus 6 squared. And again, these could be the other way. Equals c squared. 9 plus 36 equals c squared. 45 equals c squared. So I'm going to be showing you a lot of ACT kind of tricks and tips kind of mixed in. I don't like doing the whole day where I just give you a blank test and you guys do it, because that to me isn't useful. So we're going to mix those in for the next couple of weeks until ACT is coming up. And for most of you, that's going to be in March. So one of the best skills for ACT is to be able to look at an answer and go, that doesn't make sense. 45 for this side of the triangle. And this is where a lot of students stop because they get to a number and C's on one side and that's it. But 45 doesn't make sense. You could not have any triangle, much less a right triangle, where you had 45, 6, and 3 as the sides. So we do want to take that square root. Okay, and then the square root of 45 is going to be about 6.7. Okay, and that answer makes a lot more sense. Okay, it's still the longest side. It's a little bit longer than one of the sides, but that's okay because the other side is fairly short. But again, 6.7 makes a lot more sense than 45. Okay, pause now if you need to. We're going to do one more. Let's do the one down here, because on this one we're looking for a leg. Okay, now again, we can call that a squared or b squared. It's not going to make a difference. Okay, so there's my setup, again, with that longest side being c. So we're going to get 100, and then let me just double check that. 14 squared, 196, yep. Okay, and then we need to get x by itself, so we're going to move that 100 over. And then again, 96 doesn't make sense here. 1, because you couldn't even have a triangle that existed that way. And 2, c needs to be the longest side, and 96 is definitely bigger. So we do need to take that square root to get rid of that square. So we're going to get about 9.8. Okay. Now, today we're going to be looking at three things. We're going to be looking at finding ratios, which if you were in class, you saw that last time. If you weren't, that's fine. You're going to see it today. We're going to look at finding an angle, and that's going to be it for regulars today, and then finding a side. Okay, for regulars, that'll be next time. For honors, you'll do that today as well. So that being said, we need to remember our trig ratios. Okay, now again, for honors, you do need to know all six. For regulars, we're not going to worry about these. Okay, these only pop up in calculus, and then really all they are is these ones flipped over. Okay, I don't want to get into it with everybody though, because it's not really super needed. But again, it's something that just you should be aware of, that those are just the flipped ones. Those problems typically turn into problems where a guy goes to the store and buys 42 watermelons. Those are the super forced math problems. It's easier just to use sine, cosine, and tangent. So that being said, don't forget we have our mnemonic device for this. Okay, now we do need a triangle to base this off of. Oh, better one. Okay, now on a triangle, it needs to be a right triangle, and I need to have an indicated angle that I care about, in this case, theta. Now, the trick here, and this is the spot that most, if you're going to mess up, this is where students mess up, because they don't take the time to label their triangle. Let me show you how to do that where you're never going to mess this up. You're going to start in the corner you care about, okay? And it's always going to be the marked angle. You're going to draw a line coming out of that angle, okay? It can be a little up, a little down, not going to make a difference. You're always going to hit the opposite side. The only way you can mess this up is if you did something like this, where you don't draw a straight line. Okay, draw a straight line, you'll always hit that opposite side. From the right angle, we're going to do the same thing, and we're going to end up with the hypotenuse. And then whatever's left over is our adjacent. Okay, so this is how I'm going to label my triangles. Okay, red's going to be opposite, hypotenuse green, adjacent blue. Now for the three main trig ratios, we're going to do sine of theta is equal to the opposite over the hypotenuse. The cosine of theta is equal to the adjacent over the hypotenuse. And the tangent of theta is equal to the opposite over, oops, wrong color, over the adjacent. Okay, so there's my three main trig ratios. And again, the other ones would just be those ones flipped. Nothing complicated there. And then the mnemonic device we typically see in math is SOHCAHTOA. So it comes from the first letter, SOH, so ka toa. Okay, there's tons out there. If that one doesn't work for you, that's fine. Just find one that works for you. But you are going to need to know those three. Okay, so that being said, what do I do with those? Okay, well, I'm gonna do this a little backwards. So I know here it says 1 that we want to find the 6. We're just gonna do the 3. And again, honors, just make sure you do the ones flipped. But first, we're actually going to look for the missing angle here. Okay, so we're going to start off by doing the missing angle, and that's again to break this up a little bit, and then we're going to look for those ratios. I'm doing the angle first on purpose, and you'll see why in a second. Okay, so for these, we do want to label them. Okay, we want to be careful because my indicated angle is up here, and that's fine. Okay, it's fine that it's up top. Again, if that bothers you, just turn your paper. We're still going to just start up here. We're going to draw the line coming out. You'll hit the opposite side. Hypotenuse. And whatever's left is the adjacent. Okay, so for these problems, this is the next, so the spot that I see students mess up the most is labeling their triangle. So make sure you're taking that time to draw those two lines. You'll never mess it up that way. The other spot students mess up is not knowing what to do next. Okay, I'm gonna break it down for you. Which two sides do you care about? Which two sides have numbers or variables? In this case, the opposite side and the adjacent side have stuff. There's nothing on that hypotenuse. Okay, I don't care about the hypotenuse side here. I only care about the opposite and the adjacent. So I'm going to go back to my three trig ratios. I'm going to find the one that has opposite and adjacent. Okay, well, that's going to be tangent. So I'm going to come here. I'm going to write tangent of theta is equal to, and I'm going to give myself a little space here. You'll see why in a second. Is 12 over 5. Okay, opposite over adjacent. Okay, so nothing fancy here. Okay, tangent of theta equal to opposite over adjacent. That's the setup. Okay, and that's the hardest step for a lot of students. Okay, but again, just figure out which two sides you care about, which trig function does that match up with. Okay, that being said, how do I get rid of tangent? Because the goal is to get rid or to get theta, which is just a variable. It's just like x, y, or z by itself. Well, let's take a step back. Let's go back to math, like 8th grade math, 7th grade math. If I had 3x plus 2 equals 8, you would subtract 2 here, and you're subtracting 2 because it's the opposite of addition. You're doing the opposite, right, to get rid of this. And then I'd have 3x equals 6. And remember, multiplication is happening here, and the opposite of multiplication is division. Okay, we're just doing the opposite to get rid of something. If I had x squared, like we did on the earlier problems, I would square root it. Okay, I'm doing the opposite to get rid of stuff. So the question then becomes, what is the opposite of tangent? Well, we call that either inverse tangent or arctangent. They mean the same thing. And it's right here above the tangent key. So here's my tangent key. Here's my arctangent or inverse tangent. Okay, so I'm going to do that to both sides. I'm going to say tangent inverse to this side. Golden rule of math says if I do it to one side, I've got to do it to the other. So there we go. Okay, this is going to cancel out just like stuff canceled out here. I'm going to be left with just theta over here. Okay, now here's the important part, and here's the part to be super careful of because you've done everything right so far. I want to make sure you get the right answer. In your calculator, there are two ways you can represent an angle. You can represent it as radians, which we'll talk about later, and you can represent it as degrees. If you represent it as the wrong thing, you will get the wrong answer. By default, the TI-83, TI-84, TI-89, and most Casios default to radians. So we need to make sure our calculator is in the right mode. So if I was to reset this calculator, okay, and then I went to mode, you can see here that I am in radians. Okay, so I just want to scroll down, go over to degrees, and hit enter. Please make sure you're in degrees because otherwise you're going to get the wrong answer even though you did everything right. Second quit. I'm going to do second tangent. That's going to give me that inverse tangent or that arctangent. And then I'm just going to do 12 divided by 5. Okay, and I get about 67.4 degrees. Okay, now I do need that degree symbol up there. Otherwise, I do have to assume you're in radians. Okay, if you ever get an answer between 0 and 1.5, I would double check that you're not in radians. Because if I put this in and I didn't change it, this is what would happen. Okay, I get this really small number. Okay, and can I have an angle of 1.1 degrees? Sure. Or 1.2 degrees? Sure. But it's very, very rare. Okay, I'm going to go ahead and tell you most of your angles should be between about 10 and 80 degrees. Okay, if you get one that's a little bit bigger, a little bit smaller, maybe. Okay, but if it's between 0 and 1.5, you are probably in radians. Double check. If you're in degrees, then it's just a really funky triangle. Okay, but that's how these problems work. So we set them up, and then we just evaluate. Okay, I'm gonna do a couple more of these, and then I'm gonna come back and actually solve what this problem meant for us to solve. Okay, so for here, again, we're gonna do the same thing. We're gonna have that triangle. Okay, and I've got an angle theta, tells me that it's an acute angle. Okay, and then it tells me what the sine is. Okay, so if I was looking, and again, we're gonna do this part later, if I was just looking for that angle, well, it already gives me the equation here. Okay, but let's go ahead and set it up just to be sure. So we wanna draw that line, opposite, hypotenuse, adjacent. Okay, now sine is opposite over hypotenuse. Come on. So 4 and 7. Okay. Now again, the setup's already done kind of for us here, which is kind of nice. So we're going to say the sine of theta equals, we're going to put some space. Now we used inverse tangent for tangent, so it would make sense we're going to use inverse sine for sine. Okay, again, sines will go away. I'm going to plug this into my calculator. Now, a student asked me today, it was a really good question, and I do want to check my mode here real quick. Student asked me today, and it's a really good question. Should I just leave it as 4 over 7, or should I figure out what 4 over 7 is and put that in? Leave it as 4 over 7. If you don't leave it as 4 over 7 and you round, a 0.1 difference can be a 10-degree difference. Like it's a huge difference. So we want to make sure we're using the most exact answer possible. So just leave it as 4 over 7. So we're going to do inverse sine. 4 divided by 7. And I get about 0.8 degrees. Okay, so these aren't too bad. These are actually pretty straightforward. Okay, so again, want to label my triangle. Opposite. Oops. Right color. Hypotenuse. Adjacent. The two sides I care about are opposite and adjacent. So we're going to use tangent. And again, we're going to do this part later. We're just looking for the angles right now, so we can get that practice. 3 over 4. Inverse tangent. Inverse tangent. Do it to one side, need to do it to the other. Let the calculator do the rest of the work for us. Inverse tangent, 3 divided by 4. So theta is equal to about 36.9 degrees. Okay, so that's it. That's all you have to do for these first ones. Now, the other side of this is the ratios, and that's what these questions were asking originally. So let's look at that. So finding the ratios, I'm going to start off. To find all the ratios, I need to know all 3 sides. Okay, so for the 3 sides here, I'm going to do, that bothers me, sorry, 1 second. Oh, don't do that. Okay, whatever. I need to find that hypotenuse. So we're going to do the Pythagorean theorem. So 5 squared plus 12 squared equals c squared. We got 25, 144, c squared, 169, c squared, square root, I'm going to get 13. Okay, so once I have the 3 sides, now I just need to find the 3 ratios. Actually, let me put that in the right color. So there's no confusion. Okay, so sine of theta is equal to the opposite over the adjacent. So 12 over, or sorry, opposite over hypotenuse, sorry. Cosine of theta is equal to the adjacent over the hypotenuse. And the tangent of theta is equal to the opposite over adjacent. Okay, and that's the trigonometric functions of the angle. Okay, you'll also see this written sometimes as the ratios, which is you're going to see in the homework today. Okay, and that's what you do for these. The other thing you might need to do, like on this one, okay, is first label the triangle. And that's the only difference here is I need to label that triangle first. And then I would do the a squared plus b squared equals c squared. Okay, and then get that last side and then do this again. Okay, if you're regulars, you can stop the video now. You're good. If you're honors, keep watching. I do want to go over just those other ones. So cosecant of theta, again, it's just going to be this flipped. So it's going to be 13 over 12. Secant of theta, it's going to be 13 over 5. And cotangent of theta is 5 over 12. Okay, so that's the only difference on those is just those flipped. This pops up in calculus a lot. Okay, so I just want to get it kind of in your brain that it's just those ones, the original three flipped, because it's going to be important for you later. Okay, again, if you have any questions, feel free to reach out to me, and I will see you guys next time.